Hey everyone, today we're working on the linked list questions in the LeetCode roadmap. So for linked list questions, the general idea is quite similar to two-pointer in that we keep track of 2 pointers within the same linked list. So with 2 pointers, we can keep track of one and another to have the next one continuously point to the previous one to reverse the order of a linked list, or can have one travel twice as fast as the other one to find the middle of the linked list or to detect if there's a cycle in the linked list. Or we can use the pointers of different linked lists to compare their values and merge the lists. So let's get started on the first question, reverse linked list. So in reverse linked list, we're given the head of a singly linked list. We want to reverse the list and return the reverse list. So in the example here, we have a list 1 pointing to 2, pointing to 3, pointing to 4, pointing to 5. We want to reverse this list and return 5. So 5 points to 4, which points to 3, points to 2, points to 1. So we are going to do a similar idea to two-pointer in that we're going to have 2 different pointers in the linked list, one ahead of the other, and we'll have the next one continuously point to the previous one. So to run an example, it'll look something like this. So our linked list is going to look like 1, which points to 2, which points to 3, points to 4, points to 5, and this points to null. Remember, it always points to null to indicate the linked list ends. So what we want to do is we want to have null be pointed to by 1, which is pointed to by 2, which is pointed to by 3, pointed to by 4, pointed to by 5. And there's a null at the end, but it's not pointing to anything. So basically, we're just switching the order of every pointer in this linked list. So starting off, we can have 2 pointers, one called previous, prev. Let's let that be head. So the first one, or the 1 here, we can have the current one called cur. Cur is head.next, so the next one that head points to, which is the 2 here. So we also need to have the 1 point to null after we assign 2 to cur already. So we can have head.next equal to none. So we can do a while loop. So while the current one is not none, while cur not equals to none, so while we haven't reached the end of the linked list yet, we should create a temporary one, which indicates the next one that the current one points to. So temp equals to current.next. So now we want cur not to point to 3 anymore, but instead to point to 1. So cur.next equals to previous. So now we move both the previous pointer and the current pointer up by 1. So previous equals to cur, and cur equals to temp. So temp was the one we assigned, so 3. Current is up at 3 now, and previous is at 2. So after this is done, we can just return previous. So what returning previous does is, because cur is none, it's at the very end, this is cur. So previous is the 5, so we want to return previous or the 5. Let's try running it. Runtime error. So none type has no attribute next. That's because we're trying to get the next one from a null head. So all we have to do is if head equals to none, let's return none. Try that again. Nice, okay, that worked. So let's try submitting it. This algorithm is O of n based on n is how many nodes there are in the linked list, since we go down the linked list a single time and do the reversal on every single element. Nice, so that worked. And moving on to the next question. So merge 2 sorted lists. We're given the heads of 2 sorted linked lists, list 1 and list 2. What we want to do is merge the 2 lists into a single sorted list. So basically we're splicing the nodes of the 2 lists and combining them in an order that it's sorted. So here we have list 1 being 1, 2, 4, list 2 being 1, 3, 4. So what we want to do is return the 1s together, then the 2, 3, 4 in sorted order. So in the other examples, there's some lists that are empty, and we want to just return the ones that are not empty. Okay, makes sense. So in this question, we are going to do another 2-pointer approach, except the 2 pointers are the heads or the current elements of the 2 different linked lists. We're going to compare which one is smaller and append that to our final result linked list. So to make this simpler, because we're not sure which list is smaller at the beginning, so we're not sure which one to start off with, let's just create a dummy variable. So this is a dummy head, which is just a list node. And our current indicator in the final sorted array is going to equal to dummy. So to get our answer, we just have to return dummy.next, which is the head of the sorted list. Because we're not sure which one we're starting off with, we need to do a test. So while list1 is not equal to none and list2 is not equal to none. So while we have elements in both of these lists, if one of them is empty, we don't have to compare them anymore. So while they're both not empty, if list1.val is less than list2, I forgot the if here, .val, then cur should take list1. So cur.next is equal to list1, and will move list1 down to the next element. So list1 no longer points to 1, it points to 2. 1 equals to list1.next. So otherwise, we should take the value from list2. So cur.next equals list2, and list2 equals to list2.next. After that, we want to move cur to the next one that we just assigned. So cur equals to cur.next. So after we're done with this while loop, either list1 is empty or list2 is empty. So one or the other. So suppose list1 is empty. So if list1 equals to none, that means there's still elements left in list2 that we haven't added yet. For example, the 4 here in this case. So what we want to do is cur.next, we want to attach the remainder of list2 onto our sorted final array. Final linked list. So cur.next is going to be list2. Otherwise, we want to append the remainder of list1. So cur.next equals to list1. So as we said, we can just return the dummy.next. So this is the head of the sorted linked list. So let's try running that. Cool, okay, that worked. Try submitting it. So this algorithm is O of m plus n, where m is the length of the first one, and n is the length of the smaller one, because we're not sure which one we want to append first. So suppose one is really short and another is really long. We don't know where to put the shorter one, so we need to check all the elements in the worst case scenario. So that worked. Moving on to the next question. Reorder list. So we're given the head of a singly linked list. The list can be thought of as L0, L1, all the way to Ln, and -1 to Ln. And we want to reorder it so that it's L0, Ln, L1, Ln-1, L2, Ln-2, and so on. So we're not modifying the values in the linked list, instead we're switching the places of them. So the example here, we have 1, point to 2, point to 3, point to 4. What we want to do is 1, 4, 2, 3. So basically we're taking the second half of this linked list, 3 and 4 here, switching the order so that 4 is first, and then alternating the first half and the second half into our combined resulting linked list. So in the end, we don't want to return anything, we want to modify the head in place. So there's a couple steps here. So the first step, we want to split the linked list in half. So step 2, we want to reverse the second half. And step 3, we want to alternate the two halves to form our answer. So we can tackle these steps one by one. Remember that step 2 is actually done in the first question, so we can take the function from that and just use it directly. But to split the linked list in half, this is where another two-pointer approach comes in, where we have one linked list node travel twice as fast as the other one. So let's call them slow equals to head, and fast equals to head dot next. So starting off, slow is at 1, fast is at 2. So at every iteration, slow travels 1, so slow travels to 2, and head travels 2 times, so it travels to 3, and then it travels to 4. So this way, by the time the faster pointer reaches the end, the slower pointer will be at the middle of the linked list. This is a common way to find the middle point of a linked list in O of n time. So while fast and fast.next. We want to make sure the next pointer to fast is also not none, because we're going to move fast down 2 times. So fast equals fast.next to get no null pointer exceptions here. And slow equals to slow.next. So fast moves down 2 and slow moves down 1 in each iteration of the while loop. So after that, we need to reverse the second half. So let's call the first half L1, second half L2. So this equals to L1 starts off with head, and L2 is reverse. I think this is the name of the function, reverse list of slow.next. So in this case, slow is going to be 2. So the start of the second half is going to be 3. So slow.next. And we want to make sure slow.next. So slow is 2. Slow's next is equal to none. So we don't have a cycle in the linked list. So we can go to our previous question and copy this method over. So format it a little bit. So we have the reverse linked list function. We don't have to type that in all again. So after that, we have our L1 and L2 list heads. So while L2, we're doing while L2 because the second linked list, the second half is guaranteed to be at least as long or shorter than the first half. So for example, in the case of an odd number of elements, the first half is 1, 2, 3, second half is 4, 5. So the second half is shorter than or equal to in length. So all we have to check for is while L2 is not equal to none. So let's do that, not equal to none. So cur.next, we want to start off with the first half. So we're still starting with the first element here. So cur.next equals to L1, L1 equals to L1.next, and cur equals to cur.next. After that, cur.next equals to L2. So we're alternating between L1 and L2. L2 equals to L2.next, and cur equals to cur.next again. So after that, we're not sure if there's one more node in L1 or not. So we're just going to do cur.next equals L1. So if it's none, it's okay. It's at the end of the array anyways. If there's one more element, we're going to append that element to the answer. So after that, in our answer, we're going to say head equals to dummy.next. So instead of returning dummy.next like the previous question, we're going to set head equal to it because the question says we want to modify in place instead of returning anything. So let's try running that. So missing one, because we have self as a parameter. This is a function in a function, so we don't need that. We don't have the variable cur. Right, we haven't made cur or dummy. So let's make those two variables. Dummy equals to list node, and cur equals to dummy. Let's try running that again. Cool, okay, that worked. So this question is still O of n runtime, where n is the length of the list. So first we're splitting the list into 2 halves. That's an O of n algorithm. Then we're reversing the second half, which is again O of n, and we're alternating the 2 halves to form our answer, which is still O of n. So doing O of n 3 times is still O of n. So we have an O of n algorithm. So moving on to the next question, remove nth node from the end of list. So given the head of a linked list, we want to remove the nth node from the end and return the head of the linked list. So here we want to remove the second node from the end, which is going to be the 4. So 1, 2, this is the second node from the end. So the end result is going to be 1, 2, 3, 5. In example 2 here, we want to remove the first node from the end. So we just remove everything, then we get an empty linked list. Example 3, we remove the first node from the end, so we drop the 2, and all we're left with is the 1. So how do we get the nth node from the end? Or actually, we need the n plus 1th node from the end. So in this case, we need the 3, so we can have 3's next point to the 5 instead of to the 4. So this effectively drops the 4 from the linked list. So we're going to have a slow and fast pointer approach. the fast pointer is going to be n places, or n plus 1 places, ahead of the slow pointer. So we know that if we move them together at the same rate, the fast node is going to reach none, or the end of the linked list, and then the slow node is going to reach the n plus 1th node from the end. So let's do that. Slow equals to head and fast equals to head. So we're going to move the fast pointer n places, or n plus 1 places ahead of the slow pointer. So for I in range n plus 1, fast equals fast.next. So let's move them both together at the same speed. So while checking fast is not none, let's just code this out. Fast equals fast.next and slow equals to slow.next. So now we want slow.next to equal to slow.next.next. So 3's next, instead of being 4, it should be 4's next, which is 5. After that, we can just return the head of the linked list. So one problem here is that in some cases, for example, example 2 and example 3, we're dropping the very last element. So we can't move past n plus 1 places. So for example, example 2, we move 1, 2 places. That's going to be a null pointer exception because we're calling next on none, or one's next pointer. So instead of doing for I in range n plus 1, we actually need to split this up into for I in range n. So we move back n places, and we move back fast equals fast.next later. So between these, we need to do a null check. So if fast equals to none, so if fast equals to none, what does that mean? That means we moved back n places and we reached a null pointer. If we moved back n places, that means we're dropping the very first element. So if dropping the very first element, we can just return the second element, which is head.next. So let's try if this works. Nice, okay. So again, this is the key part for this question. If we're dropping the first element, for example, case 2 here, that means we moved back n places when we do for I in range n, we move back the entire linked list. So if the fast pointer is none after moving back n places, that means we know we're dropping the first node. So if we're dropping the first node, we should just return the second node, which is head.next. So let's try submitting that. Nice, okay, that worked. So moving on to the next question, copy list with random pointer. So a linked list of length n is given such that each node contains an additional random pointer. So this random pointer could point to any node in the list, or it could point to null. So we want to construct a deep copy, which is a new instance of every object, except they have the same properties. So the deep copy consists of exactly n brand new nodes. So we're going to need the new init function for nodes, where each new node has its value set to the value of its corresponding original node. So the new node can just be initialized with old node.val. So both the next and random pointer of the new nodes should point to nodes in the copied list. So the pointers in the original list and copy list represent the same list state. The pointers in the new list should not point to nodes in the original list. So, for example, if there's two nodes capital X, capital Y in the original list, and capital X dot random equals capital Y, then the two corresponding nodes, lowercase x, lowercase y, so lowercase x dot random points to lowercase y. So this question is a little bit complicated. We can look at the diagram here in example 1. So it's a linked list, except each node also has another random pointer. This points to just some random node in the linked list. What we want to do is we want to create a deep copy, so a new instance of every single node in this linked list, copy their next pointers and copy their random pointers. So we can create a new function called def_getNew. So what this does is that it returns a new instance of every single node in the linked list. And to get our answer, we can just call getNew on the head. So we also need a map or a dictionary in Python called new nodes, or old to new. So what this does, it maps every single old or existing node to a new one that we're going to create. So this way we know if we've created one or not, because the trick in this question is that, for example, some pointers like the 7 points to the 13 points back to the 7. We're not going to create a new instance of the 7 because we've already created it. That's what's calling create on 13, sorry. So in get new, first, if we should take in parameter, we should take in the parameter old node and also the map, which is old to new. So if old node equals to none, if we're at the end of the array, obviously we don't want to do anything, so just return none. So if old node in old to new, that means we've already created an instance of it. We don't want to create another one, so we're just going to return that one. Old to new at old node. So otherwise, we know that we need to create a new instance of this node. So what we're going to do is new node equals to list node. This calls the init function, and what we're going to pass in is old node.val. So it has the same value as the old node. So new nodes, old node. So we're adding this new node to the map to make sure that we never create it once again. So new node. So new node.next equals to get new. So what this is doing is we're calling getNew function to create a next node and create a random node. So new node.net random get new old node.random or new and new nodes. Old node.random new nodes. So what are we doing here? We're creating a new node for the next pointer, and we're creating a new node for the random pointer. Except this getNew function checks if we should actually create it. If we actually create it, then we'll create it with a linked list node init function. Otherwise, we're just going to return the corresponding mapping from the old to new dictionary. So after that, we should return what we just created, so it's the new node. Let's see if that works. Oh, we need to pass in the dictionary as a parameter, so let's pass in old to new. And new nodes, oh, it's old to new. That's the name of our map here. Time limit exceeded. Time limit exceeded. Oh, we're calling .random here, so it should be new and random. Oh, next. See if that works. Cool, that's accepted. So this question, we're creating a new copy of every single node, and then we're also creating new copies of their next pointer and their random pointer. Except we need to make sure that if we've created a copy before, we don't need to create it once again. So moving on to the next question. Why is this page not loaded? Okay, so add two numbers. You're given two non-empty linked lists representing two non-negative numbers. The digits are stored in reverse order, and you may assume the two numbers and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. So you may assume the two numbers do not contain any leading zeros except for the number 0 itself. So let's look at the example here. example 1 has the numbers 2, 3, 4, 2, 4, 3, except the numbers are stored in reverse order. So what it's actually saying is that the number is 3, 4, 2, and 4, 6, 5. So 342, 465. So what are we doing here? We're adding these two numbers. So when we add numbers, we're going to start from the lowest digit. So we're going to add the 2 and the 5, that gives us 7. Add the 4 and the 6, that gives us 10. 10 carries over, so we have 0, and 3 plus 4 plus the carry, that equals to 8. So in this question, we're going to create a new linked list as our answer. So let's create a dummy head for the answer, just like the previous question. So dummy head equals list node, and let's create a cur pointer pointing to the dummy head. So we also need a carry variable to check if we have a carry at a certain point. So now we're going to iterate down list 1 and list 2 in order. So if either list 1 or list 2 has not reached the end, so while L1 or L2, v1 is the value of L1 or L2, so equals to L1.val, but we would want to do this only if list 1 has not reached the end. So if L1 not equal to none, let's just do if L1, else 0. So v2, we do the same thing. v2 equals L2.val, if L2, not eval, just val, else 0. So val here equals to v1 plus v2 plus carry. So what does carry equal? Carry should be the value divided by 10 rounded down. So if value is over 10, carry is 1. If value is under 10, then carry is 0. So we need to create a new linked list for the digit we're storing here. So cur.next equals to list node val mod 10. So in the case that val is 10 or greater, we're going to round it down by 10 because we're storing the carry in the carry variable already. So move cur down by 1, cur equals to cur.next. So now we need to increment L1 and L2. So L1 equals to L1.next, but only if L1 has not reached null yet. So if L1 else none, L2 equals to L2.next, if L2 else none. So there's an edge case here where we reach both the ends of L1 and L2, but we still have a carry. So if carry equals to 1, we're going to need to create a new pointer. So cur.next equals to list node, and the carry can only be 1. It can't be higher than 1 because we're adding two one-digit numbers. So cur.next equals to a new list node with the value 1. And what we want to do is return dummy.next, just like the previous question. So let's try running that. Cool, okay, that worked. Nice, so this question runs in O of n time. We're just traveling down list 1 and list 2. We're getting the value, creating a new linked list node to store that value, and we need to create one more with the value 1 in the case that L1 and L2 both end, but there's still a carry. So moving on to the next question. See if that works. Cool, that's accepted. So this question, we're creating a new copy of every single node, and then we're also creating new copies of their next pointer and their random pointer. Except we need to make sure that if we've created a copy before, we don't need to create it once again. So moving on to the next question. Why is this page not loaded? Okay, so add two numbers. You're given two non-empty linked lists representing two non-negative numbers. The digits are stored in reverse order, and you may assume the two numbers, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. So you may assume the two numbers do not contain any leading zeros except for the number 0 itself. So let's look at the example here. Sample 1 has the numbers 2, 3, 4, 2, 4, 3, except the numbers are stored in reverse order. So what it's actually saying is that the number is 3, 4, 2, and 4, 6, 5. So 342, 465. So what are we doing here? We're adding these two numbers. So when we add numbers, we're going to start from the lowest digit. So we're going to add the 2 and the 5, that gives us 7. Add the 4 and the 6, that gives us 10. 10 carries over, so we have 0, and 3 plus 4 plus the carry, that equals to 8. So in this question, we're going to create a new linked list as our answer. So let's create a dummy head for the answer, just like the previous question. So dummy head equals list node, and let's create a cur pointer pointing to the dummy head. So we also need a carry variable to check if we have a carry at a certain point. So now we're going to iterate down list 1 and list 2 in order. So if either list 1 or list 2 has not reached the end, so while L1 or L2, v1 is the value of L1 or L2, so equals to L1.val, but we would want to do this only if list 1 has not reached the end. So if L1 not equal to none, let's just do if L1, else 0. So v2, we do the same thing. v2 equals L2.val, if L2, not eval, just val, else 0. So val here equals to v1 plus v2 plus carry. So what does carry equal? Carry should be the value divided by 10 rounded down. So if value is over 10, carry is 1. If value is under 10, then carry is 0. So we need to create a new linked list for the digit we're storing here. So cur.next equals to list node val mod 10. So in the case that val is 10 or greater, we're going to round it down by 10 because we're storing the carry in the carry variable already. So move cur down by 1, cur equals to cur.next. So now we need to increment L1 and L2. So L1 equals to L1.next, but only if L1 has not reached null yet. So if L1 else none, L2 equals to L2.next, if L2 else none. So there's an edge case here where we reach both the ends of L1 and L2, but we still have a carry. So if carry equals to 1, we're going to need to create a new pointer. So cur.next equals to list node, and the carry can only be 1. It can't be higher than 1 because we're adding two one-digit numbers. So cur.next equals to a new list node with the value 1. And what we want to do is return dummy.next, just like the previous question. So let's try running that. Cool, okay, that worked. Nice, so this question runs in O of n time. We're just traveling down list 1 and list 2. We're getting the value, creating a new linked list node to store that value, and we need to create one more with the value 1 in the case that L1 and L2 both end, but there's still a carry. So moving on to the next question.